All right, so I've got a project going on here that has been sitting in a pile for about 2 or 3 years. Figured we would start looking into making it happen. So what is this thing? What are we doing? As you can kind of tell, it is probably very warm outside today. It is. It's not blazing hot, but it's warm. You just stay hydrated and cool. And that brings us to the subject of heat pump water heating, which is what this project is. So we're going to build a heat pump water heater, a retrofit heat pump water heater that you could actually retrofit onto any standard tank style water heater. So it's like an outboard, attachment water heater that turns your existing electric or gas fired tank into a heat pump. Also, can also be heated with a heat pump. So how's it going to work? Well, the easiest way to do this, that I think is to take an old window air conditioner. You can find them, go on Craigslist and find a junky old window unit. You want something that's decent, not too worn out, but it doesn't have to be pretty. You get yourself one of those, and then we start taking it apart. So I already took the thing apart. Here's the base, the fan, the two coils, the two heat exchange coils, the air to refrigerant heat exchangers, all the insulation and everything. And then the heart of the matter is the compressor, which is right here. This is a 6,000 BTU window unit. So it's got a little compressor. These compressors are much more powerful than what you would find in, say, a refrigerator. So this compressor is from a little refrigerator. That is not what we're going to use. We need to use a window air conditioner compressor. We need to have that higher capacity to compress the refrigerant. A fridge would work, it just isn't gonna heat your tank very fast. All right, so this compressor is gonna give us lots of heat. How does it work? Well, it's just air conditioning in reverse. So the air conditioner takes heat out of your room and it blows it outside using a refrigeration cycle. In thermodynamics, we would call it a Rankine cycle, named after a guy named William Rankine, which we won't get into the history of it, but this whole process allows us to take a material that can boil and condense, that can go from liquid to vapor, and then from vapor to liquid, depending upon the pressure and the temperature that's applied to it. So we're going to use refrigerant, and this compressor was originally designed for R22. Right, R22 is, I believe, it's like chlorodifluoromethane or something like that. It's a HCFC refrigerant. It is obsolete. It was ceased manufacturing in 2020. R22 is no longer being produced. The R22 that was in that window unit had escaped at some time, who knows when, but when it was taken apart, there was no gas left in it. I think it got mangled here on the corner. So, what am I going to use instead of R22? Well, there's lots of options. There's all kinds of refrigerants that you can buy that are similar to 22 to retrofit in here. But we're going to be a little bit on the wild side. We're going to use this magic gas right here, propane. So propane is also known as R290. Propane is an excellent, absolutely excellent refrigerant. It is one of the best refrigerants. with one problem. I think we know what that problem is, right? It's flammable. So you just got to make sure that anything you're putting this into, you don't have a huge quantity of it. So if it leaks, you aren't filling a room up with propane. But we're only going to be using a few ounces of gas in this unit. It's just basically a window unit. We're going to be running long refrigerant lines like you would have for central air. We're going to be keeping it contained to the footprint of the window unit. And I'm just going to take that window unit base and put all the components back on it and utilize what was the condenser coil of the window unit, the outside part. We're going to turn that into an evaporator, and then we're going to use the same fan, maybe the same fan. We'll think about the fan for a minute, but and then that will be our evaporator that will capture the heat from the room here and convert the propane from liquid to a vapor. So I want this to be as energy efficient as possible, but it is also an experiment, and it is built out of a window air conditioner. So things are, they just need a little bit of tweaking to make sure that they work as intended. So with the fans that are in those window units tend to be really crappy capacitor start PSC motors. I'm thinking about using a bank of computer cooling fans, DC powered cooling fans instead. Number one, it'll cut down on the noise, and those fans are more efficient because it's a brushless DC motor versus a AC simple design PSC motor. So we'll save some watts there. The other part of it is, okay, if you're going to build this on the base of a window unit, how are you going to heat water with that? Well, we are going to use the existing gas water heater tank. We're going to keep the gas, everything's going to stay exactly the way it is, with the exception of fittings will be added probably on the hot water discharge line and on the port on the side where you would drain the tank out. The other place I'm thinking of possibly adding a T is at the temperature and pressure relief valve. So put a brass T there with a nipple and feed the hot water back into the tank at the top where the pressure and temperature relief valve is at. So that's the blow-off valve on the tank. You want to basically take the cold water off the bottom and put the hot water in the top of the tank. So I'm going to use a circulator pump. So this pump is designed for pumping hot water. This would be here. It would take the water from the bottom of the tank and force it through. This is going to be a brazed plate heat exchanger. I don't have the heat exchanger here. That's the one part that I didn't buy yet. But we will purchase a brazed plate heat exchanger, appropriately rated for pressures. And we will pump water through one side of it, and we will pump propane through the other side. So, how's it work? It's very, design-wise, it's pretty elegantly simple. I mean, you've got let's just start over here. We got the fan. The fan blows air from the room, let's just say 70 degrees Fahrenheit, over the coil containing the refrigerant. In this case, the refrigerant will start off as a liquid. So we got liquid propane right here, and it's going to be low pressure, so it'll be cold. It'll absorb heat from the room. And as it absorbs the heat, you'll hit the boiling point. It'll convert to a vapor, and the propane vapor will then travel to the compressor. The compressor will pump up the pressure to, higher level. And ideal gas law says that higher pressure is going to give you higher temperature, and that propane will come off that compressor very hot. At least 130 degrees, probably a little hot, probably even higher than that. I hope it gets higher than that. Based on the pressure temperature chart for propane, I'm looking at probably somewhere around 280 psi, 290 psi, something like that. Vapor pressure coming off the compressor in order to get my required temperature to heat the water up. Now that pressure could vary depending upon system conditions. So if we send a slug of cold water in here, the condenser will condense the propane very fast, and it will lower the pressure on the discharge, because the compressor is basically just pushing a fixed number of molecules through there, kind of just pushing them through. It's a positive displacement machine. So they pushes them through. So depending upon your condensing conditions, the pressure here will vary. But if we're running 130 degrees of the temperature going into it, it's going to be about 280 psi. And then after we condense our propane back to a liquid, we will meter it through a capillary tube. At least we're going to try a capillary tube at first. I don't know. We got cap tube off the window unit. I don't know whether it'll work or not, but we'll figure it out. And force the liquid propane through that little tiny diameter capillary tube that creates a very large pressure drop. And then the liquid propane oozes out the other end, and it hits low pressure on the suction side of the compressor. And boom, it wants to convert to a gas. It evaporates and it gets very cold. Then the gas, I should say that process kind of happens all along this coil. It doesn't immediately happen there. But the liquid gets up into this coil. The heat from the room boils the gas to a vapor. We go back and we recycle it all over again. The propane stays in the system. It doesn't get burned. It's not supposed to leak. You want it to stay inside, just like an air conditioner would keep its refrigerant in the coils, in the lines, in the system. So that's going to be how it works. So it will be interesting. So I'm going to use basically some kind of a temperature sensor that will go on the water heater tank. So I'll probably have to peel back on the top, where maybe where the anode rod is or something like that, where we would mount the temperature sensor to sense the temperature of the water in the tank. We'll try to maybe stuff a thermistor or a LM35 sensor under the insulation so we get a good tank temperature reading. We send that temperature reading to a controller of some kind. Probably just use a little on-off controller, some relays, and we'll control all these different motors. So we got to control our compressor, our water pump, and our fan, and come up with a sequence of operation that optimizes the functioning of the heat pump water heater. So that's the plan. Converting the junky old window unit into a heat pump. The great thing about it, like I said, you're using electricity, which in my case I can get that from solar power, and it really isolates you from buying the energy from the utilities. But if something happens, if this breaks down, or if the electricity goes out, because I have a grid-tied solar system, so it would not run when the power's out, you can still use natural gas to heat the water. The challenge with that is there's a pilot light in the tank. And if you're not using the water, that pilot light will actually keep that tank hot. It will not, there's enough heat given off by the pilot light to maintain a pretty close to maximum tank temperature. But as soon as you start using the water, it just drops and the main burner comes on. But I'm going to have to see how it behaves with the pilot light. I don't really want to be shutting the pilot light down and relighting it, because that stresses out the thermocouples. You want your thermocouple to be functional, so when you got to run on gas, it works. Right? You don't want to be having a dead gas powered side, but if something did happen to the gas components, run the heat pump. You've got redundancy for your water heating. But the bigger, probably even bigger reason that this is so great is because it serves as an air conditioner and a dehumidifier in this basement. So this is going to get cold enough to condense moisture out of the air. So that will actually provide extra heat to the water heater. When we condense water, we condense any substance, it gives up its latent heat of evaporation to the wherever it's condensing on and heats it up. In this case, it's going to heat up the propane and boil it. And then we're going to collect that condensation in a tray and we're going to send it to the drain, just like we do with the dehumidifier. But instead of just blowing the heat into the room after we condense the water, we're going to put it into the tank. And I'm going to take a shower with it or wash the dishes with it. And then in the wintertime, if I run my steam heating, this basement gets it stays at a nice temperature, but it doesn't need to be as hot as it is. And this will help to capture some of that heat. So the boiler, I've got everything pretty nicely insulated, but it still throws off a lot of heat. I mean, it's a steam system, so it's 212 degrees, water sitting there. And this will take some of that excess heat and put it into the tank. And it will be an interesting thing to see how it works. Worst case is in the wintertime, you don't run the heat pump. You shut it down and you just run on gas if it gets too cold. But these heat pump water heaters are commercially available. You can buy them, not this kind of design, but you can buy an integrated tank style heat pump water heater. And they've been out for well over a decade now. And they get very good reviews. People really like them. And even those commercially available tank style electric heat pump water heaters also have a backup heating element in the tank that you can use if this system fails or if it doesn't heat it up fast enough. You can go down and there's a boost feature on those units that will allow you to run it on electric elements and circumvent the heat pump. Of course, paying dearly for that. So, because typical electric water heater has 4,500 watt elements in it. I mean, people get all freaked out over what it takes to charge an electric car, but we don't realize you have a water heater in your basement that uses 4,500 watts when it heats the water up, and that water heater is 15, 20, 25% of your electricity use. It's a very significant amount. So all the worry over electric car charging, we're kind of already doing it with water heaters. Let's get rid of all those clunky resistance heating elements if we can and convert to heat pumps. Now you have enough power to charge your car without any changes in much change in the generation mix. So that's the project. We've got all of our tools to do refrigerant work, vacuum pump, all that stuff. Got the gauges. And this project obviously will be performed outdoors when I'm assembling it so that we are not releasing propane into a confined environment. But once it's all sealed up and good to go, then we'll bring it inside and hook her up. I'll probably use rubber hoses to connect the water side of this to the tank water heater. Maybe PEX or something like that, rubber or some kind of flexible material. And that can be disconnected if needed, like washing machine hoses would be good for this. And put a little shelf up beside the water heater and let it run. So that's the plan. Heat pump water heater using propane as a refrigerant.